Well, good morning, everyone. My name is Eric Marsky, and the net lab that we have for you today is actually how to conduct an RF site survey. This is kind of a continuation of the series that we've put together, and my name is Eric Marsky, and I'm the Manager of Strategic Partnership Development, and do a lot of the field work here at ESTEEM. So what I want to do is kind of give you an idea, those of us that aren't really familiar with who we are and what we do, we'll kind of give a quick overview really of the company. So what we want to do is kind of start with something very simple. You know, who we are. We actually were established back in 1982. We've basically been building nothing but radios and wireless systems for over 38 years now. We are the manufacturer. We do all of our own design. We do all of our own software. Everything that we do is in-house. So it's very important that we basically keep all the ownership of everything inside. Everything's made here in the U.S. and manufactured. The headquarters and the manufacturing facility are up here in Washington State. As of now, we have one of the industry's most comprehensive lines, both in licensed frequencies from products that cover everything from 150 megahertz all the way to 4.9 gigahertz in the licensed frequency bands. We also have unlicensed frequency bands in the 900, 2.4, and 5.8 gigahertz. So you can see why, you know, selecting and using the correct technology for the application that it goes into is a key element to designing this. To date, we really have over 45,000 different radios in service worldwide. These are ones, at least that we know of, that we can track. What ESTEEM really provides is solutions for many different industries. Water, wastewater is a great application for it. Oil, gas, mining, material handling, power and energy, agriculture, infrastructure, factory floor, AGV kind of applications. All of these really kind of fall under some standard overall design applications where it's either a long distance or inaccessible areas where that may be not necessarily difficult to get to, but just inaccessible by means of any other means. It's a parking lot, a airport, across a waterway, things like this, where wireless really stands in itself. It's really come a long ways in many, many years. So the last webinar that we had was actually done by Dan Tolley about optimizing mesh technology. And this is actually the second net lab that we've covered. And really what it is that we want to look at what are the steps to making a successful radio network. So in the first net lab, which I recommend everybody get a chance to, we've actually saved it. It's both on our YouTube channel and it is actually on our website for how to do the first step, which is the RF system design. That is the mathematical calculation of, is the equipment that we've selected going to allow us to operate the system that we want to be able to do? Is it going to provide enough bandwidth? Is it going to provide enough distance? Is it going to provide the requirements that we have for a successful system? What that does is that gives us an idea then, is the hardware that we are looking to install going to solve our problem? If everything looks good there, and there are steps that we worked through on things to become familiar with when doing the RF design, if all of that looks good, that's then going to take us to phase 2, which is what we're going to discuss this morning, which is how do we conduct basically an on-site radio survey. Primarily what we're doing is we're doing a physical inspection and testing so that we can confirm the results that we got during the RF system design. The RF system design is a fantastic tool, but it doesn't cover everything. It doesn't cover everything from trees, buildings, overhead power lines, you know, man-made noise, other transmitters. These are the things that can only be tested, measured, and actually found ways around actually during the site survey. Ultimately, what we want to do during the site survey is come up with a plan so that we can put together the site survey report, and we'll put in there some of the elements that we're looking for here in a minute, so that we can actually give this to any contractor and they can successfully install the wireless hardware so we know it's going to work. The last stage in here, which is the site commissioning, quite honestly, performs the exact same test that we're going to do during the site survey. The only difference between it is during the commissioning, you're doing it on the actual installed hardware, so that we know that we can pass the system off to the actual operating system, to the operating network, and we're going to be confident in its success. Why this is important is it seems like a tremendous amount of work, but we need to understand what we're building here. We're building the backhaul for the entire network. So if we have a bad communication link anywhere on there, everything that's connected on that communication link is going to have a problem. So this needs to be the most reliable piece within the system. And it can be as long as these steps are taken. So what am I talking about here? What we're talking about here is actually going out, setting up the hardware in the application area to where it's going to be used, and test to see what things that we need to change or what things we need to modify. Where do we install it? What is available to us for installation? What's happening in the RF environment? It gives us a much more physical understanding of what we're expecting to see. So what is an RF site survey? Well, really what we're doing is we're developing a plan on how to actually install the hardware. So we start this off with the RF design system, as we talked about before. We're gathering information that we can get things from maps, site layouts, things like this. Sites that are going to be used as repeaters, sites that are behind mountains. These are the things that we know we're going to have difficult communication to. Doesn't necessarily show up on the RF design, but we know that we're going to have issues with it actually on the installed system. So we're out there to do it. So what we're physically conducting is the next phase is the on-site measurements itself, where we conduct the RF test results, we measure the received signal strength, and we determine what's the best pathway for the RF communication to take. The final thing is we're gathering site information, physical constraints. What is there buildings there? Are we going to need towers? Are we going to need to be aware of like environmental changes? Is there smokestacks? Are we near water? Are we going to need to put this near a seaside? We're going to have salt air, things like this. Each one of these physical elements needs to be evaluated to make sure that we actually put this together correctly. So what are the steps? The steps are quite simple. First of all, we just lay the system out. We actually covered a tremendous amount of this part when we did the RF system design. What we're going to do during the site survey now is actually do a physical site inspection, or what we call a site walk down, where we look at each one of the sites, gather an idea of the type of test equipment they're going to need. In a lot of cases, we use to test height, we actually use a bucket truck or any kind of a lift so that we can basically create an artificial height and to be able to test where the antennas will actually physically be mounted and the amount of signal strength that we're going to get at those. Bucket trucks are fantastic because they give us the ability to adjust the antenna height to make sure that we're either getting a line of sight to the remote location or adjust this received signal strength until it gets to a point where we need to. Once we've done this, once we've done a physical inspection, we know kind of an idea of what it's going to take to do the site survey. We do what we call a pre-test preparation. Anytime that you do an RF system, an actual physical test of it, you'll always want to make sure that you test that hardware before it actually goes out. Most of the time, I'll test the hardware before we leave, and I'll test it once again once I actually get to the physical site. Because there is nothing worse than doing a 10-mile communication test. You get out to the remote site, plug everything in, it's not working, you start looking for a repeater site, it's not working, you go back and lo and behold, well, the base radio, we didn't have something connected. So what we need to be able to do is do this pre-test preparation before we actually leave. Once this is done, then we go out and actually test each site within the system. Once that's done, all the sites have been tested, we've gathered all the data we have. Do we have everything that's necessary to complete the site survey report? So let's take a look at each one of these in a little bit more detail. So when we're talking about the site layouts, what we're really talking about here is we originally covered everything. We used to do most of this by just simply reviewing the maps, finding out which sites are going to need repeaters and get kind of a pre-test preparation to make sure that we understand which sites we're going to need to facilitate, which sites we're going to need to test in multiple areas. But now we did most of this during the site design, the RF system design, like we covered in our last net lab. During the site walk down, we're going to be looking for things that don't show up during the map model, things that will block the line of sight, as I mentioned to you before, trees, buildings, overhead power lines. We're going to look at the antenna height and structure. Another thing is that you're going to need routing of the feed lines. If we're going to be mounting a remote antenna, we have to run a coax cable to it. So is the height that we want to get on the opposite side of where the equipment is going to be installed? That does all the advantage that you got out of the height on one side of the building is going to be lost in the length of the coax cable. So we need to consider each of these as we go through it. The next thing is, of course, environmental considerations. As I mentioned to you, whether we're talking about salt air outside of a very foggy environment, things like this, each one of them needs to be considered to make sure that we have a solution for getting that system to run. So where do we start? Well, the first thing we're going to do is we're going to start with what we'll call just a reference site. Now, this usually is the master location, or at least the central location, and we kind of work our way out from there. But really, the reference location is any point within the system that we're going to test into. So that reference site is actually going to move several times during the site survey. It may start at the master site, and then we move our reference site to, say, a repeater site. Each one of them is actually installed and tested the same way. The first thing that we'll do is we always install the antenna as close as we can physically install it to where it's finally going to be installed, as close to the real world environment as possible. So we may put it on a tripod on a roof. We may temporarily install it on a handrail in a water tank, something like this. Once an antenna is installed, though, every time it is an antenna and a coax cable is installed, we want to be able to test that antenna site, because it does not take much for a small minor crack or something like this to absolutely skew the results. So anytime an antenna is put into installation, especially a remotely mounted one, we always want to be able to check the forward reverse power, or as you see here, the standing wave ratio, or the SWR. Once we've done that, we actually then need to take essentially a spectrum analysis. A spectrum analyzer allows us to physically see what's happening in this invisible world we're working in. It gives us the ability to see how much intensity is on any given frequency. So what we do have a net lab actually coming up here on how to actually run or how to operate a spectrum analyzer. You can see here I actually have a spectrum analyzer kind of on the shelves behind me. They're a very, very specialized tool, but what it does do is it gives you the ability to physically see what's happening in this RF world, which is one of the most challenging parts, right? Because we're dealing with an invisible entity. Okay, we aren't able to see what's happening or see where things are going. So we have to have these tools that allow us to measure it. The spectrum analysis, the purpose behind this is we want to find the most open area that we possibly can to do both the testing and also for recommendations. So if it's a licensed radio system, we want to make sure that we're testing on licensed frequencies. All the licensed frequencies, all this documentation and the database, at least in the US anyways, is actually all on the FCC website. It is actually a very, very powerful tool and fairly easy to work with, quite honestly. The next thing is that we've now looked at the available channels. We need to choose one for testing. We want to look for the most isolated one, as much as we physically can get. The reason for that is we can trust our own radio equipment. We can't necessarily trust what's going to be happening with other people's equipment. So we want to give ourselves as much area as we possibly can do. Now, one quick note that we have on here is I have it listed here as the quick connect test. This is one of those things that you unfortunately learn by experience, but I'll go ahead and give you kind of it to you for free here. Before you actually go out and do any kind of remote testing, and we have our reference site set up, we have our antenna installed, it's already tested, we have our radio, before we actually physically leave that location, set up a quick test with inside of your car and set up whatever you're using for testing, and just simply, can I make a simple connection back to the master site? Can I do a ping test? Am I able to see that remote site? What that's going to do is that's going to verify that your frequency is correct, your everything is installed correctly, your addressing is correct. There's nothing worse than getting out to a remote location, having no communication, start looking for a repeater site, set up your repeater site, still having no communication, going back to the master site and finding that, oh, I simply had the wrong address in there, or I set it to the wrong frequency. Unfortunately, it's one of those things, it happens, okay? And just trying to give into you by experience that It is avoidable if you do that very simple step before you leave the location. So now that we've established our base radio, we've established our reference point, we then now are going to start going to the remote locations that communicate to this reference point. What we want to do is we really want to start with what we call the most questionable site first. We used to say that this would be the furthest location, but there are sites within the system that we know are probably never going to get communication to, ones that are beside a hill or many, many miles away. There's no reason on testing those back to the master site because you're really just kind of wasting your time. We know we're going to need a repeater site. But those that are coming out that are the most questionable, the ones that we have the most concern with, will want to do those first. The reason for that is if we go out to that site and find that we don't have communication at all, we now know that we're going to need a repeater site. And that when we test that repeater site, not from the repeater site back to the master, but now we can actually go, we know which sites are going to need to use that site as a potential repeater site. The best thing is that almost all of our radios have the ability to be used as both a remote location and a repeater simultaneously. You can create these very complex networks with just minimal amount of hardware. So these kind of tests allow us to move around and allow us to adjust how we want the system to work. Once we've established that site, we've gone to the site, again, we're going to install and test that antenna. Now, if you're dealing with an antenna at the higher frequencies, and you're going to either directly mount it or going to actually use the small little jumper piece of cable that goes to it, there's really no reason to actually go to a full-blown checking of the forward reflected power of the SWR. A physical inspection on most of those antennas will be satisfactory. You can tell if something is cracked or broken and all the seals are correct, okay? Once we've established this, then actually what we need to do is just do a simple quick connect. And depending upon the radio itself, that can be as simple as typing in a connect to a remote, or even if we're using the newer generation of radios like the Horizon, you can simply look and see is the status light on. If a status light on, we know that we've got at least a baseline level of communication. It doesn't tell us how well we're working, but it tells us at least we've got something. If we don't have that, we don't have a minimal amount of communication going from our test point to our reference point, we know that now we're going to need to start looking for a repeater site. We're going to look for another way of getting communication, either raising it up, finding a repeater, whatever it takes to get communication to that site. If we have established that we've got a good connection, there are two main things we need to know. What is the received signal strength? In other words, how much signal is getting to that remote site? And then we actually put data across that network to see how well it's actually functioning. There are a couple different ways to do that. So our narrowband radios, they aren't necessarily based on IP or have an IP address themselves, but you have the ability to actually go in and measure the diagnostics through the utilities. Now, some of the other radios like the Horizon series, which run on IP level, you can actually just run a TCP ping. Because what that does is that pushes data out to the remote site and sends it back to you to tell you how long it took to do that and how many times did it actually lose that communication. It's a very, very powerful tool. So now we know how we can connect to it. We know how much signal we're getting to that remote site and how well it's operating. If all that looks good, we can then pack up our equipment, move on to the next remote location, and perform this exact same test again. And what we're going to do is we're going to test that communication to all sites within the network. Now, how do we actually measure the received signal strength? Well, it's actually become very simple actually in the Horizon series. Inside of the radios, they will actually tell you how much signal they're receiving. And you can actually do that by simply just going to the wireless status menu. It'll be listed as a peer within there if you've got them linked as a peer communication. It'll also tell you the last time they received an update and also the actual RF data rate. On those that don't necessarily have the received signal strength meter built into them, you can of course use a spectrum analyzer. The difficult part about a spectrum analyzer though is on a spread spectrum system, it does not tell you the combined signal strength that it's receiving. That's why it's a very, very powerful tool when you're looking at radios that are spread spectrum to use either the modulation calculator in a higher level spectrum analyzer or actually utilizing the radios themselves, because they'll tell you not only just how much the peak is, but actually how much signal we're getting across that entire band. The beautiful part about a spectrum analyzer is it also gives you the ability to see what is happening, not necessarily on the frequency you're looking at test, but what's happening on the outside of that. Okay? What we're looking for when we're conducting these RF site surveys, we want to give ourselves at least a 10 dB above the minimum signal strength for that fade margin. Fade margin is kind of what we covered in the last point, but really what it is, it's a small over design of the system to account for things that are going to happen over time. Signal's going to run out of alignment, antenna's going to move, we've got environmental considerations. We need to make sure that we essentially create a buffer zone in there. The only thing that I can guarantee is if a system is designed with a 0 dB fade margin, in other words, it's designed to absolutely work today, it will fail over time. So we do know that we need to add that much signal into it to make sure that we cover our bases into the future. Now, most of the equipment that we do is in a fixed point environment, okay? For those communication paths, just think of it this way. Every one of those paths needs to be tested. Whether we're talking from the remote to the master site, whether we're talking from the master to the repeater, and the repeater to the master, each one of those communication paths needs to be tested. We also want to conduct a long-term testing, preferably an overnight test if possible, so that we can see that the radios are actually functioning during a time when we're not necessarily there taking the communication tests. Okay. The only other thing that changes in there is that if you've got a system that is in a mobile environment, what you're really going to have to do is you're going to essentially conduct the same type of communication testing across the entire area where it goes into. They can take a little bit longer because there are several different considerations that need to be done, but of course it can be done. These same general rules still will apply. Okay. So what should we have when we're done? What kind of results should we have? Well, we need to make sure that all sites within the system have a signal strength that allows us to basically give that 10 dB or greater fade margin. Now, in a lot of times we conduct our RF testing with lower gain antennas, lower gain hardware, so that we know that when we install the final hardware, it itself will be above that minimum 10 dB. Doesn't mean you need to necessarily test it. If you test it with the lower gain equipment, great. It's only going to get better into the future. But we need to make sure that we calculate in at least that 10 dB fade margin. The next thing we should be able to have is the bee should know how much antenna height and where they're going to be located at each one of the remote sites. We also have the ability, we also want to know what operating frequency we're going to test on. Because in a lot of cases, we may need both a primary and an alternate. Even if you're going into a licensed system, okay, the channel that you're testing at, by the time it gets to, licensing from the FCC, you may find that that channel has been taken. So we need to make sure we've got a couple different channels there. Having an idea of what's happening in the background noise, which is a fantastic tool for the spectrum analyzer. It tells you how much essentially general noise is in that area. We also need to make sure that we've got the testing data from each one of the sites, from each one of the sites in the system, and preferably an overnight to the furthest location. So what should we have to complete this site survey? Because what this site survey report is, it is a how to build diagram. So we need to make sure that all site test results are listed there. We need to also put in there a system layout. Who's going to talk to who? Which site is going to be used as a repeater in a mesh network? What is going to be the primary? What is going to be the secondary? What is going to be the tertiary routes for each one of these pathways? We also, within the site survey report, can create an accurate bill of materials. We'll know exactly what the cable lengths are going to be, where the antenna types are going to be, where they're going to be installed. So we can create installation instructions. So we can hand this document off to a contractor, and they can then build a reliable network based upon the tests that we've done. We can mark in their safety concerns, overhead power lines, things to this. So what we also want to be able to do is put on there what program commands are in there. So what's going to be available as far as which sites are going to be used as the masters, which sites are going to be in a mobile environment. We also should be able to, which is the reliable operating frequency and license information. Once we have all this, We can then put into our site survey report what we expect for the results, so that we know that when we hand this off, we hand it off to whoever's going to be putting into, they're going to have a reliable communication system. It's not difficult. It's just a matter of understanding that each one of these tests, these are the exact same tests that we perform when we do site testing, when we go out and do troubleshooting, and ultimately when we commission the radios. So it's very, very important to understand these overall concepts. So the next webinar that we're going to have is actually how to conduct a radio system using what we call a hybrid network. It's a very, very challenging system because we have so many different radios. We now can create networks that are not only a combination of long backhaul licensed systems with high bandwidth, we can then jump off of those and go into smaller networks that get better penetration. So that will be coming up here in a couple weeks. So I hope everybody gets a chance to sit in on that. The big thing is that if anybody has any questions, I'll try to take those questions now. We've actually had our chat window open for questions since the beginning of this. If anybody doesn't have any questions at this time, though, I'll be happy to answer them into the future. Of course, you can always reach me at my email address, or you're also welcome to call me at any time on the phone, area code 509-735-9092. And you can just ask for Eric Marsky. I'll be glad to help you out. So if nobody has any questions at this time, I really want to thank everybody for sitting in with me today. And you have a fantastic day. Thank you.